using the commutative and associative properties. In kindergarten through first grade, students learn to add. For example, 3 plus 5. They can count on and start with 5. 5, 6, 7, 8. They are using the beginnings of the commutative property, and they learn about this property. As their addition strategies become more complex, they will use both the commutative and associative properties. Let's take a look at this example, 19 plus 35 plus 46. Here you can see that students first are adding the ones. They have 9, 5, and 6. Notice they can move the add-ins, commute the add-ins, if you will, and think of it as 9 plus 6 plus 5. That way, they get to a friendly 15 plus 5 more to equal that sum of 20. Notice how here they're using both the commutative and the associative properties. If we took a look at the tens in this problem, we can see that we have 10 plus 30 plus 40 plus our 20 that we just added within the ones. Now, once again, we can combine those in ways that are friendly for us. Notice we associated the 10 and the 30 and the 40 and the 20 to then get 40 plus 60. The commutative and associative properties are also used to solve multiplication problems. So let's take a look at 24 times 35. You certainly could use the algorithm or the partial products algorithm, but another way to do this would be to factor the 24 into 8 multiplied by 3 and factor the 35 into 5 multiplied by 7. So you would end up with 8 times 3 and 5 times 7. If we switch things around and turn it into 8 times 5 and 3 times 7 and associate those factors, makes it a little easier. Now we have 40 times 21. So we have taken our problem 24 multiplied by 35 and simplified it into something we could probably solve mentally, which is 40 times 21. So why do we do this? Why do we write out the properties and talk about the associative property and the commutative property? Well, mathematical practice number 3 tells us that we need to construct viable arguments. Sometimes viable arguments are difficult for students to construct, but at this level, it's a good way to show how you went, step by step, showing a logical progression of how you solved the problem, and you can prove that what you've done is correct based upon the properties. Do I suggest that we write out all these properties? No. But can they? Yes, I think it is a way to be explicit with our teaching, keeping in mind that these properties will continue to live on as they step into algebra. It is these building blocks that will make that connection between what they know about arithmetic and how it connects directly to algebra. They'll see that connection.